Good afternoon. Welcome to the stream. We've got hopefully some fun things to do today. Um, really happy with how last week's stream went. We got the collisions fixed, which is huge. Um, and I think that understanding how that works is going to be really helpful for some of the other things that I'd like to do today. So, so we should be able to, get going on some more interesting game mechanics. At some point, I would like to change our collision detection from rectangles to capsules, um, but we might put that off and do maybe go to switch our collisions to Rapier 2D. I haven't researched that yet, so that's just sort of speculation right now. But yeah, it's looking really good. I think we've got some opportunity to improve some things and get some more interesting stuff into the game. So um, if you all are still enjoying this Bevy content, I'll keep doing it. I have some other ideas for things to do on stream in the future. For example, a friend of mine is working on his PhD and he's got some really interesting programming language research. I also have a project in my back pocket that I've been wanting to do for a while, which is also in the programming language space. So we'll consider doing those sorts of things later if we get tired of working on this. But I think we've got an opportunity to kind of get this beyond the very basic mechanics and I don't know, get some interesting terrain in our level. Um, we need to restore some things that we disabled while we were debugging the collision systems, and then maybe we can think about things like whole new mechanics like power ups or or being able to pick up different weapons. So weapons that do different things. Um, and I might just while I'm thinking about it, I previously shown you all. Hi, Mitch. I'd shown you all Crafty Survivors, but the original one that I played of this kind was Vampire Survivors. And so we might look at some of the mechanics that they have and see what might be interesting to crib from that. So let's see, get Steam over here, and then we'll get started. So Vampire Survivors update queued, so I need to update that, and then we can show some of that off. Cool. So let's get started going. And so I've pulled up LDTK here. We were playing with this recently. Last time we created a wall on our map that was just to demonstrate that we could have a wall inside the map. And I think that we've got some things that we could do there, but we really just verified that we have the right um, the right mechanics for our wall collisions. So I made a little list here. Um, One thing that we need to fix is we are currently spawning enemies anywhere in the game space. So, and I say anywhere, they're like remember our one of our first streams, we spawn them at a radius around the center of the game space. And really, what we should be doing is either picking some places for them to spawn from, um, based on the level dimensions, or we can just spawn them outside the player's view, but inside the level. And we just need to figure out how that's going to work. We'll do some of the same stuff as we did for the wall collisions by looking at the LDTK level data, and hopefully we'll get the information that we need there. There's some dead code in our project that if we can just delete. And then one thing I would like to do, because we're already doing it with the level, we could probably get rid of most of this, the asset loader, because we're using individual tiles here. And what I would love to do is use that sprite sheet like the level does. So, we've got the LDTK file there, and it's pulling from this tile map packed file. So we could probably, I hope what we can do is figure out how to load that and use it directly for our weapons and for our spawns. So okay, so let us get started. Right, so here's our to-do. I'm gonna save this real quick. I'm giving up on oh, come on, Zed, don't crash on me now. That's not good. Okay, save as. Sometimes it's not so much the editor itself, but sometimes the integration with the operating system is just not great. Can we rename that? Here, let's just, we'll do it like this, to-do.text. Okay. Then it's an actual file. And my cat just shook the whole desk. Cool. All right. So let's go over here. We have. I noticed that we weren't keeping the enemies inside the level because we had disabled that when we were trying to debug the player, and the enemies were spawning outside the level. So we disabled this keep inside walls system, which was, we could potentially, instead of parameterizing it like this, we could potentially run it where the component is just a marker component for this thing needs to stay inside walls, or this thing collides with walls, and then it wouldn't need to be generic like this. We could maybe make the player bundle include a component which was like the stays inside walls bundle, or stays inside wall component. Yeah, that's an option, and then we can apply that to the ghost. So let's look at the ghost. We didn't make a bundle for the ghost, which is surprising, and we're just doing this. So maybe we should, yeah. Okay. So let's start here and make a bundle for this, and then we'll clean up that code. And this is going to have ghost, and I might need to split this so I can see. Yeah, let's split down. Key combo. What's the key combo? I forget. Oh, that gave me multiple cursors. Command K down. Okay, so we can go down here and so we previously did a sprite bundle. I'm not going to change this right now. damage, collision damage. We're just going to group this together into a struct that we can spawn more easily, and then we will make, let's make a default for this so that we can capture all this stuff here, and then this is going to be interesting. Maybe what we do instead of a default, maybe we do new, and then parameterize the stuff where it's like based on where it's spawned here. So right, so these spawn with velocity heading toward the center. Yeah. Okay. So this is going to return self, and we'll figure out what the arguments should be. So we know that, let's get the stuff that's kind of static in there. We know that that's going to be collider, is going to be collider new ghost size, damage, ghost damage, and then we can worry about the things that are parameterized. Right? Okay. So let's do the sprite is a sprite bundle, and here's where we're going to need some arguments. So we're going to put default in there first. So we're going to need the sprites is going to be res. I don't know, maybe we can do without borrowing that res sprites assets. It might already be a smart pointer. I mean, I assume it is. Okay. And then we can get the texture in here. So that's going to be sprites ghost clone. And then we want to, so we computed the spawn spot, right? Which was in this square. We'll want to change this later, but that's not a big deal. Okay, so we need the spawn spot. We'll call it spawn at for fun. Okay, and that's going to be a vec3. And we'll do, don't help me so much. Oh, Jesus, wow. So the transform is going to be a transform from XYZ. No, not from XYZ. From translation. Oops. And we'll give it spawn at. Okay, so there's the sprite bundle like we did before, and now we need finally the movement bundle. Wow, I was getting really aggressive with these tooltips. And that's going to need a velocity. Yeah. and that's velocity from direction speed. And we'll just say it has a direction that we'll pass in, ghost speed. Okay, so we're just factoring this out into a function that we can, and direction is a vec3, okay. Okay, let's close this split now that we have that. So we can go down here to where we're spawning this, and we can get rid of this, and we can say ghost bundle new, and it's going to take the sprite assets, and it's going to take the spawn spot, and it's going to take direction. So now this can be concerned with where do we spawn, and we can at a later point pick up the LDTK level information and determine a place. So we might do something like grid position and convert it to the spawn spot to the actual direction or the actual position inside the level based on the grid position and so forth. So for now, let's just ignore this stuff, and we will move on. Okay. Let's make sure we're all good. Run that. Okay, so fine, we don't need debug on this bundle. It's just a bundle. Okay, then we can get this. Let's, what did I do? Did I break it? Did I? Oh, I know what happened. I removed the camera entity from because we were spawning the camera. So I think what we need to do is we need to get rid of this and let's we'll make a spawn camera system, and that's really just going to spawn the camera 2D bundle. In fact, we can probably get rid of this. Let's make sure though that, right, so this is selecting camera. Camera is a Bevy entity, a Bevy, not entity, it's a Bevy component. So we can do just this and it'll be fine. The camera 2D bundle includes that as well as the orthographic projection, so I think we're fine here. Let's get rid of this. I think it was ill-conceived anyway. It was just a quick way to get the camera looking at the player. And we will probably want to revisit this camera follows player thing again as well. So that's why we weren't seeing anything. So let's get the camera spawned. Right, okay, so we're still following the player. There's some jankiness with let's see, kind of not moving smooth. Like the camera's moving smoothly, but the player is jumping around. So we might need to look at that. But at least we know this is still working, so that's good. And now maybe let's consider the thing in our to-do. So spawning the enemies inside the level, and then we can re-enable this keep inside walls. The other thing that we could do is add the like contained in wall component, and just put that on player and on any of the enemies that we spawn, and not worry about having these specific marker components. Okay. Right, so let's look at what we did in levels. We did a lot of work. This is mostly copying the code from the platformer example in the Bevy ACS LTDK repo. But what I want to look at is how it makes use of these queries. So mostly like the level query, the projects, and the project assets. This will give us the information we need, I believe, to know how to spawn our enemies inside the level that we're currently in. So let's go down and find where they first use this level query. Okay, so they loop through the level query. But what they're doing first, where's this level entity? Oh, right. So here they've made a map. Well, because we did this last week, of all the wall locations for each level, because each level is an entity. For example, if we go over here and we look at their anatomy of the world, so there's the world bundle. The level entities live inside that, so they're child entities of the world bundle, and they each have a level IID component. So that's what comes from the editor. And then there are the layers inside each level, so they're all children of that. And we've got entity layers and the other kinds of layers. So, right. So looking back at this, we've got an entity which is each of the levels as the key here, and then there's a hash map of the grid coordinates, which is just like X and Y, right? And then we put in there because this was a hash set, we put in there the set of tags associated with that coordinate. So that's how we got the ability to adjust the bounding boxes of our colliders. Okay. So they're looping through the walls. Right. So if we added a wall tile, so we're not actually caring that much about that when we go to check our spawning position. Really, what we need is that there's not anything at that same grid coordinates. That's going to be interesting. Okay. Okay, so if there are walls, then we go through. So level query is all the entities that have a level IID. Okay, so those are all the levels. And then we're expecting, so the LDTK project assets is an assets for the project. Okay, so expecting that to be there. And then as standalone, okay, so internal levels, right? Okay. And then it gets the loaded level by the IID. Okay. So what I'm getting here is that when it loads the file from the editor, it doesn't put any of this metadata on the level entity. It's a separate. It's stored in the project, so it's not duplicated across that. So this is why we have these additional. This is why we have these additional checks, these additional pieces that we have to pull in. So you get a layer instance, and what else is on this layer instance? There's a lot. Okay, so we have the height and the width, which are the dimensions by tile. Okay, and then we have the grid size, which is why we are getting that complaint about not needing that constant. Okay. And then there's auto layer tiles, entity instances, grid tiles, int grids. So we might need to look at the int grid. The other option is that we could. Let's go down here and look at how we're computing what the transform is, because what we could do potentially is pick a spot, like find the closest grid location of the player, and then try to randomly pick a spot that is near or that is away from the player but inside the level. And you might have to do something like what we did in the previous or the existing system is we picked a random angle and projected that onto, so the random angle gives us a unit vector here, and then we project that onto a square rather than a circle, so we're dividing by one of the dimensions. And then we expand that to a arbitrarily sized rectangle. So what we might do would be similar is do this, but do it in a short loop until we find a spot that's not occupied. Because what you don't want to do is spawn the enemy at a random distance from the player, but on an object that it's already colliding with. So we want to spawn it on a wall. We want to spawn it directly on the player. We might not want to spawn it on top of another enemy. We haven't really talked about, should enemies be able to walk over each other. I think that's sort of like a gameplay decision. But these are all sorts of things that are going through my head about this. So we could start with this random angle, and then we could potentially use it to choose a grid coordinate first, and then convert that grid coordinate into a transform. So when we loaded the levels here, and we were, building up these plates until they created rectangles, which represent the walls. Then down here, after we have the stack of plates, we okay, so we built up the rectangles. Okay, and then we spawn for each of the wall rectangles. So this is that computation of you know adding up the dimensions and multiplying by the grid size to get an actual world space rather than a grid space transform. So we could do something like this. Right, and here they're saying the center point of it is between the left and the right and the bottom and the top. Multiply by the grid size. And then we had these adjustments here for our collider. Okay. So honestly, what we really need is we need to get the position of the player. So maybe let's write this out. Find the position of the player. Convert to grid coordinates. And there actually is a there is a utility function in this project. Bevy ECS LDTK. Sorry about the. Here, let's go dark. There's this utils function. So they have grid chords to translation. I wonder if we can get here translation to grid chords. Right, so we can get the translation as a vec2 and the grid size as an ivec2, and that'll give us the grid chords. Let's see how they implement that. Yeah, so this I think this as ivec2 is probably truncating any remainders on that. Yeah. Right, so the grid chord space is less detailed. Okay, so let's start. We're going to need some more of those things that we had in the other system where we were spawning the walls. There's also, we're going to need the level selection, I believe, which I don't remember where we set that. Oh, right, level selection index 0, right. So we start with that. So we might need to get the level selection to know which level we're in, because this is spawning entities. Oh, bless you. My cat just sneezed on me. This is spawning for every level. Okay. Yeah, so let's get this stuff in our system. Okay. So this is going to give us we're going to have to do some stuff with this. So we're going to need the player. And what we could do potentially is if the player does not exist, then we just spawn some distance from the origin of the level. So So we can start off by finding the position of the player, and then we're going to um, do our random angle thing. We're going to do this inside the if just finished because we don't need to bother with this unless the spawn timer has expired. So if this is not the, let's see, if let okay player transform, we're going to say let origin so this would be where to start from. Player dot get single. Then we want player transform translation. And looking back at this translation to grid chords, it requires a vec2. So we want to truncate that to a vec2. Okay, else we're going to do vec2 0 because it'll be the center of this world space. And then we'll say origin grid chords. We will use that Bevy ECS LDTK utils translation to grid chords. Okay, so this is where we're going to need the grid size from the level. You know, we are pretty certain the grid size doesn't change, but we're going to need to get that from the level. So we're probably also going to need the level selection. Okay. Yeah, let's look at the level selection thing. We did this, right, in ours. But when you have that level selection resource, yeah, we don't care about level set. You know, this just has some variance. Okay, so if we have a level selection and we have a level, which we can get from the resource, right? This is a bunch of stuff that we were looking at earlier. And not exactly the same thing. I remember this being kind of weird, this function, and not really understanding it. Oh, levels don't inherently store their index. Okay, I'm not sure where this level indices thing comes from. So that, if this is present, level index is used within that world, not the level used at project root level collection. So if we have, okay, so here's, So point to the level with a given index in the project preview, multi-world preview. Okay. So, okay, maybe we need to look at, right, so this just constructs that. It's interesting that this is like, does this match? So this constructor looks like it's world 1, level 2. Um, let's see if we get anything in these that will let us figure out what level we're looking at by index. So this is a loaded level struct, which looks like it's a reference into something inside the project. So let's look at that. That may give us some information. Loaded level. Wrap around a bar level guarantees the level has complete data. All right, so this is probably has deref on it. It has methods. Okay. It's the ID, but there's nothing about the index of this level. That's interesting. Okay. So, but then they're looking at layer instances. Because what we've got this duality here of the index of the layer or the level within the project file, but it also has an index. And there's no relationship. It has to be on the project, right? Like there's no relationship between those. Well, there's this. Find loaded level by level selection. And this is on LDTK JSON with metadata. Oh, okay. Okay. So, we could get loaded level by IID, but we have the index, the level selection thing. So, right. Okay. So this is after we call as standalone, then we do get loaded level by level selection, or find loaded level by level selection. Okay. Okay. I think I've got it. So we should go ahead and do the same stuff we were doing over here. Okay, so we need so we do this get single. Okay, expect project should be loaded if level has spawned. And that's like, I think we'll need to be careful about, we need to import the prelude up here. Prelude star. We need to be careful about when this runs. I think that it's late enough that it should be okay. Okay, so we get the level. This is the part that we're changing as standalone. And then we get find loaded level by level selection. And here's where we give it the level selection. And then we're going to expect spawned selected level should exist in LDTK project. Okay. So now we have the selected level, and we can, yep, we can look at this. Okay, so we've got the loaded level. Let's go ahead and get the layer instance, I believe. This will probably have I'm sorry, we did so we have the level selection. We can get the IID and find the entity. So we can find children of this level that are walls. That's something else we'll need to do. Okay. At the very least, let's get them like inside the coordinates. Okay. So we've got now we can get the grid size like we did over here. So let's go back up and look at that. Right. Level dot layer instances 0. Okay, we need to put the dot dot in there because we don't care about the rest. So now we have the grid size. Okay, so that's actually an I32, and this needs to be an IVEC2 splat of grid size. Okay, so now we can say that we know where the closest square in our tile map to where this player exists. And what is it complaining about up here? Too many arguments. Yeah, we might be able to clean that up. We can make our own queries. It'd be nice if this were something that were part of Bevy ECS LDTK, a query that contains these 4 things, or at least these 3 things. Okay, so we've got the closest grid coordinate to the player, and now what we want to do is pick an unoccupied and this is the part that's potentially difficult to spawn the ghost in. One thing that we could potentially do is make a new int-grid layer that's invisible that contains valid squares to spawn in. So maybe let's look at the editor and see if we can do that. So we have the walls and we have entities, right? And we can, restart. Okay. we need to delete this entity. Okay. Yes, it's fine. We don't care about the camera right now. Okay. So we could make a new layer. So we have the walls layer, right? The other possibility is, let's look at the rules here. We have the background. We could potentially let's look at that. We could potentially say that anything that doesn't have a wall tag on it. Yeah, let's look at the tile sets. So we had, we're using this. We have this wall direction. Let's put, let's see, data could be either numbers, JSON text, XML. We need to understand where that comes in. Otherwise, it's not going to help us. Right. The thing is, like this with being an int grid, we have there's no value there, but like there's value 1 there. Right, so we have this wall direction thing. I mean, do we just add a new value that is not wall? It's like open. Okay. Yeah, so there's like this background, but we're not applying that to the tile set because you can only apply one enum to a tile set, which is really kind of annoying, but I guess that's okay. We could say, let's call it open, and then do that because that's what our dirt tile is. We can maybe do it for some of these others if we want to like switch things up, but the other thing is we could use this custom data. I just don't know where this comes in, so we would have to look. Let's look at, is it tile metadata? Automatically inserted on any tiles with metadata. So this is probably where it comes in. What I want to, so I could envision something where we get, because we've looked at, it wasn't this tile metadata, it was tile enum tags. This component was added to our int grid. We could see about this rather than having this enum be changed. Let's just delete that. And then we could say something like, They're saying it's arbitrary, so I'm guessing that this is just text. Yeah. Let's say this is ground, and just like close that. So it says ground. Okay. We save that stuff, and then what I would like to see is before we okay, so we're going to need an additional query here, and this is problematic. We want to get the tile metadata and the grid coordinates of something that has that ground in the data here, right? Okay, so I'm going to, what is this? Clippy, too many arguments. So we're going to allow Clippy, too many arguments. So we can turn off that that mess. Okay, so what we want to do is get like ground tiles as a query, and that's going to be what we want is grid coordinates and tile metadata, right? Without wall tile. So we can ignore anything that has a wall in it. Remember that what we did was when we last time what we did was we spawned wall entities that are separate from the tiles that come from the editor. So here where we're saying the wall tile is added, we get the grid coordinates and optionally the tags for that, and but only on wall tiles, and then we ended up spawning walls, so those are separate from what's on the grid. But here we want to get tiles that are not wall tiles, so something that has grid coordinates and tile metadata. I don't know if this is going to return anything, so we'll find out. So we could potentially do this, like pick a random spawn spot, do all this computation, and see if we can find a grid coordinate that has this tile metadata equal ground. So we'll need to use some more of those utils for converting between the coordinate spaces. Okay, so let's just say we did this. And we're going to need, let's look at that layer instance struct, because we're going to need more information about we're going to need more information about what the dimensions of this level are. So this is a layer instance. Maybe that's not what we want. What's the level? Yeah, let's look at loaded level again. Let's see, level background, image pivot. This is possibly not what we want, but I'm not sure. Okay, looking at layer instance again. I would assume that the grid height and width are the same for all layers that are contained in the level. It's like we have that int grid layer, we might have an entity layer, so there's the entity instances. Let's see what this tile instance thing is. Single tile from a given tile set. Okay. Okay, mirror transformations, pixel coordinates, and it has layer offsets. Interesting. Okay. It is odd to me that potentially this information is duplicated. If you have any thoughts, throw them in the chat. Okay. So we've got the level. Let's get the C high and C width. And let's call that height. Width. And then we need the grid size. Okay. Okay, so let's assume that we can. It'd probably be a little bit janky at first, especially if the player is near the edge of the world. But what we would like to do is we'll pick a random direction from the player to spawn the enemy in, like we did before. So we want to make sure that the position is inside the level. So we'll need a clamp to the height width 0, 0, right? And then we'll have to account for, is it on a wall? Which is, or rather, we need to find the closest ground tile that doesn't have a wall tile on it, right? Okay, so let's just assume this bit works. And we're not going to use this weird 410 by 310 square. I think what we want to do, see, vector on square is a vec2. Okay, so let's do just vector equals say spawn spot we want to do vector on square. Let's just say so grid size is a I32. Let's say 16 units away. Okay, so we're picking. This is not exactly where we want to put it, but we just want to. So 16 times 16 will be pretty big. What is that, 256? That's about where we want to go. Let's see grid position. Let's Bevy utils translation to grid coordinates. So we're going to pick, let's reuse this. So and here we'll do okay. So the translation is the spawn spot. Okay, so this is the position that we want to try to spawn it at. And what we want to do is we might want to do this in a loop, right? And say is going to be vec2. And then if we can't find a spot on the grid that is unoccupied, then we'll continue the loop. Otherwise, we'll spawn it at that spot. Okay. Okay, so let's really this is what's at that grid spot, right? We want to what's there? Who's on first? So we're going to take the ground tiles, we're going to iterate over them, and we're going to find, and this is going to take, this will be the grid chords and the tile metadata. Right? And what we want to do is, maybe find is not the right thing there, but basically let's say there's some condition here. Well, I'm going to say true for a second. They say if what's there is some, then, or rather if is none. So if it doesn't match, then we'll continue. And here we're going to do for whatever, and let's do 5 attempts. And then if we can't find a spot, then we'll just give up, right? Okay. So what we want to do here is test grid position equals grid chords. Is that double borrow? Let's deref that just to be sure. And meta.data is equal to, what did we say in the editor? We said ground. Okay. This is a silly way to do it. Honestly, the maybe we should change the labels on that enum Okay, and I'm gonna remove. I'm gonna save that. Okay. Why is that a double reference? The thing is, I think grid coordinates is copy, so we can do not borrowed. No, okay, it has to be borrowed. Maybe let's do this. Okay. What do we got here? Expected vec3 found vec2. Okay. So maybe what we do here is we'll do this. Right. Okay, sprite assets, value moved here in previous iteration of the loop. That's interesting that it's moved even if we didn't. Hello, Polymathic Man. Welcome to the stream. Maybe what we can do is in our bundle here, have it take a borrow. I don't know if that's going to matter, and then we'll go down here and we'll borrow it. I think it's that Rust can't detect that. Oh, and here's the other thing is that we need to break so that it's. The other thing that we could do is, yeah, but we don't need to loop again. What's there is some. Let's do this like so. That's probably a little bit better. Creates a reference to reference. We'll get rid of the reference. It's still double reference. That's weird. Okay, so we're not using this. Oh, right. So what we want to do is pick, so translate. The other thing that we didn't do is clamp this position. So let's look at grid chords, see if it, because the one I want to know is, does it implement mathematical operations? It has add assign. Okay, so we should be able to add this to spawn spot, or rather to grid position. So let's add that. We might want to change this to an import. It's getting kind of long. There. It's a little better. Okay, so then we want to let's rename this to spawn position. Spawn chords. There we go. And let's inline that variable. Not the greatest. We want any instead of find is some. Thank you, Clippy. Okay. What are we complaining about now? Can't compare borrowed. Okay. Fun. Something else that we could potentially do is set the metadata, add a component for that metadata on spawn, but on the, and then it would be like we'd have a query over ground, or like with ground, right? Um, that might be a little bit cleaner. We might have to look into that in a future episode. Okay, so we've got where we think we want to spawn it, and then let's see if this has. It doesn't have clamp. Yeah, default from IVEC2. And we could. Does it allow converting to an IVEC2? Oh yeah, yeah. So we could say if we want to clamp it. What is this tile pose type? And that's interesting. Staggered offset. This is looking interesting. Checks to see if self lies within tile map of the specified size. Tile map size is just XY. Okay, so this comes from Bevy ECS tile map, not LDTK. Interesting. Maybe that's what we do. We can convert it to tile position and then say, is this within the map bounds? There's a question about, can we get tile map size from, say, like loaded layer or loaded level rather? Excuse me. Let's look at the raw level. Yeah. Let's see, what was that? No. I thought I saw something there that was interesting. But no. Okay. I think we're at the point where I can undo this split. So let me move it over here. There we go. Okay, so if we do, if we turn it into this, and we say within map bounds, we know we have the height and width here. So let's go ahead and say, the problem is I think we're going to have to explicitly because it doesn't re-export it, we're just going to have to do this using whatever version ECS LDTK pulls in. Yep. Because we need to pull in that. Yeah. We need tile pose and tile. We don't necessarily have to get that because we'll have it, but what was it? Tile map size? That's within map, okay. Tile map size. Okay, so let's make a does it like that? No. This takes U32s. I don't know if this is strictly necessary, but it just the LDTK stuff is not giving me the information that I need. Why does Clippy not like that? Casting the result of I32 absolute to U32. Do we just do as U32? Okay. So the goal being we get so we need to say and this might not be what I was thinking. Let's clamp it, right? I think the part that I'm worried about is that we will get a lot of problems, like it won't spawn at all if we're close to the edge of the map, because it'll try to pick spots that are outside the level, and then we won't get um, we won't get any spots that are valid. So I would love to clamp it. Yeah, this is maybe not necessary. Um, let's say clamped chords. Let's do spawn grid chords. Let's just construct one. New, which is spawn chords dot x clamp, and we're going to give a min of 0 and a max of width. Dot y dot clamp. This is probably the easier way to do it. And then we'll change this to clamped coordinates. And then in here, we need to redetermine what spawn spot is, and then we'll use the conversion back. So grid chords to translation. And this is going to take clamped chords. Probably didn't need to do it that way. Probably could have done reassign spawn chords here. It's fine. Okay. So yeah, let's just rename that. Okay, so going back over this, so we found and we don't need this. What we can do is just say let here. We don't care because we'll reassign it on each iteration of the loop. And we're going to say giving up after 5 attempts, because if we don't find a spot, we should just not spawn. Just let the timer expire again. Okay, and we're not using this. I don't know if this is correct. I think what will happen is we will find out. We're not using the level query either, which is interesting. So let's comment that out for now. I think maybe what we would need to do to make sure this is correct when we have multiple levels is maybe we create a resource that is indexed by the current level or indexed by the level ID, and contains basically this information. So we could like make a ground tiles resource that contains a hash map of level ID to a set of grid coordinates, and then we can say is this in that, and that would be more efficient. Right now what we're doing is we're searching through all of the potential entities that have tile metadata on every time we attempt to spawn. So I think this is going to slow things down substantially, and we'll need to refactor. I don't know if this is going to work. We've done a lot of coding without running the thing, so let's see what happens. It's going to be interesting. And the other thing is we might be able to unpin that ECS tile map because we didn't actually end up using their stuff. Okay, so it's spawning. Let's go up to the edge. Now they're spawning fairly close to the player, so maybe we want to increase that. But the main thing I want to make sure is when we get close to the edge here, they don't spawn out here. And it looks like they're not. That's good. So at least it's not broken. It's maybe a little bit slow. And we probably need to adjust that. Okay. So let's go. Let's in levels. I don't know if we. I don't think we have to derive. Yeah, you do need to derive resource. Okay, so here in levels, let's. So we got load levels, right? The other thing that the part of the problem is this is async, so I think that we need to do something similar to this. And it wouldn't be added wall tile, it'd be like added. Yeah, let's see. Okay, so we're gonna let's call it preload spawn spots. And what we want to do we're gonna define a resource. Default debug. Spawn locations. And actually, let's just make it a tuple struct. And this is going to be hash map of level ID to a hash set of grid chords. Okay, and then init resource, and we've got to get that the turbofish of spawn locations. So this will determine valid places where we can spawn, and then it'll be a simple hash set lookup in that function rather than iterating through all the tiles. We can determine that at load time. So we'll do something similar to this. We need let's call it spawn locations. This is going to be res mute of spawn locations. And then we're going to say, so this is a ground query, right? It's going to be query of grid chords, parent, and tile metadata. And then we need some kind of filter on it. I want to say something like added, but I'm not sure what type to put in there. Because here we were handling this when, you know, the wall tile for the wall bundle was spawned, but this doesn't have, it's not an int cell, it's not an entity, so it's not going to have any component spawned. We could say tile metadata. That should work. Okay, so we have the spawn locations, we have the ground query. Now we need to do the parent, the level, projects, project assets. All that goop again. And I think like it might be worth turning this into a query. I saw something, there's a Bevy, in the Bevy cheat book, you can define your own query types as structs. And then you can just contain them in there. You can say, give me the LDTK query or the levels query, and it'll just give you all this stuff as fields on that thing. Okay, and it, as long as you derive the right thing, it will determine how to fill in those arguments to your system. Okay, so what I want to do is basically pull out this stuff, right? We don't need to query the ground tiles. What we want to turn this into is we just get a resource of the ground tiles, or the valid spawn locations for each level. Okay, so I want to look at what they were doing with the parent stuff here. Right. So its direct parent will be a layer, not level. To get the level, you need the tiles grandparent. Okay. So this is mapping entities to grid coordinates. But what we want to map the level ID to the grid coordinates. Although we don't necessarily have to do that. Let's look back at this, because I think that we might be able to do... we get the level selection, right? That loaded level... look back at the docs again. That loaded level, I think we can get the IID on it. Yeah, we can get the unique instance identifier. So interesting that they say and string and not stir. That's weird. Okay, so multiple windows open there. Right, so at that point we can do yeah, I think that's correct. So we probably need to make an intermediate one that uses the entity. Right, and then convert the keys to the IIDs. And that will be the contents of our resource. Okay, so we'll go back up here. we're going to do say in there they did for each. Oops, wrong one. You're looking down below. Yeah, wall query for each. Okay. So let's say this is level to ground to spawn locations. And that's going to be a new hash map. And we will maybe annotate the type of that later. It says unknown because we haven't done anything with it. So let's say for tile, this is actually grid chords parent metadata meet metadata in ground query dot iter. Come on. They say if metadata dot data is ground. Otherwise, we don't care. Okay. I'm not sure we're going to need this parent query. How did they use it? Do they call the parent? Yeah, they call the parent query. Okay. So, say if let okay, do something similar to this. Parent query, parent get. Let's do that. So this is the level. Honestly, we could I kind of love to chain these, so yeah, I don't care about the without wall tile. We could say without tile metadata. The only reason that should exist is so that these two queries are not intersecting. Yeah, I know that's needed. We'll figure it out. All right, so this is to get the grandparent of this tile. Yeah. So that's a parent. And then sometimes I wish I had a, yeah, okay. Grandparent get. Sometimes I wish I had a diagram to work this out in my brain. Okay, so we've got the, yeah, so let's make this a hash map of entity to a hash set of grid coordinates. Okay. Okay, so we know that this is a ground tile. Um, and what we want to do is put that, so we'll say level to spawn locations, entry, grandparent.get, and modify insert grid chords. And we'll deref that because it's grid chords is copy. Is that what we did down here? Or no, it's or default. Okay. Yep. Or default rather than and modify. Or default insert. So you don't need this and modify because we don't need to. Okay, so we're building up a map of the entities which represent a level and the grid coordinates of spawn locations that are valid. And then what we want to do is change the key on this to level IID, right? So maybe we don't need these two things. Let's see what they were used for down here. They were for getting this information, the layer information. I don't feel like we need that. We do need the level query though. Because if the thing has a level IID and we have a tile that's a child or a grandchild of the level, we should be able to look it up. Yeah, it contains a string. Hopefully that's clone. I imagine it is. The other thing that we could do, let's put the entity back there. Because I feel like I want to yeah, okay, so we're going to do we're going to say spawn locations 0 is we're going to loop over the levels. And we're going to map so that's going to give us entity and ID for the level. And what we're going to do is do level to spawn locations, remove entity, fine. And we're going to want to do, we want the ID clone. Sorry for bumping the mic there, folks. So, or default, unwrapper default. right? Because it may not have had any, that level may not have had any spawn locations, but we want to have spawn locations for every level. And we'll collect. Okay, so this isn't the most efficient. Cannot mutate. Oh, we need mute there. It's not enough that it says it's a res mute. Okay. So this is a little messy. I don't actually care for it that much, but just to review, we're collecting all of the locations that are valid spawn spots for enemies, without annotating them in the editor, because I found that was probably going to be too tedious. So then we're looping over all of the things that have tile metadata added to them, when they get added. So this is the trigger for this. So we can run this. We have the add wall colliders in update. So we can also add the spawn spots. So let's go ahead and add that there. Preload spawn spots. Okay. So as we get tiles added that have tile metadata, we are looping through them. If their metadata says they are a ground tile, then we know it's a valid location to spawn an enemy. So for every level, we have a collection of these grid coordinates of these ground tiles. So we'll put them into this hash map, and then we'll map them to the level IID, because that's what we're going to have in the other system. It's not going to be the entity, but it's going to be the level IID. And yeah. And so if this level, these are all the levels, right? We're getting the entity and the level IID. So we're looping over that level query, and we'll pull out the ones that we've collected from this hash map and collected it into a new hash map. Again, this is not the ideal way. I would love to kind of combine these things, but these are different iterators over the world space, or the world contents. Yeah, but we are only doing this when tiles are added. So this is only happening when a level is loaded. Which means that if we go back over here, we can I think we want to keep the level information in here. But what we can do is, instead of this, we can say this is a res of spawn locations. And then ground tiles, so this is a spawn location, ground tiles.0, and that's not pub. So maybe what we'll do is we'll make a method on that. Let's do that real quick. Okay. And just say for level, and this takes self, and ID is a level ID, and this is always going to return a hash set of grid chords. So if we have a level that doesn't have any, we'll just return empty. So we say self.0, this is pub fun, self.0.get, and let's I don't want to copy it. Get ID, unwrapper default. I think there's going to be a problem with that. I think it's be as ref. No, because this already contains an option here. Get returns an option for reference. Maybe we would just return that. Yeah. Okay. So we say for level, and we want to say level.id. Oh, that returns a string. Boo. How do we construct a level IID? Level ID. I honestly think it's like, yeah. Sometimes I wonder about the APIs they created in this crate. uh, does that implement from? Yeah, from string. That returns a reference to a string, clone into. Um, that's not. Eesh. Okay, so we've got that. And then we'll say I don't think we can say unwrap or default here because it's still like, where's the reference? It returns a reference to a hash set. We could say map. The other thing we could do is go level tiles. Say let some level tiles or return else return. This will let us go, like, if there's no tiles for this level, then we have no business. And we could likely do that up here. So if there's nowhere to spawn, then there's no point in continuing. So we can say level tiles. And then that's a hash set, so we can say spawn coordinates. And that should take a reference, right? Oops. Okay, so now we've got rid of all that goop. That was the weird iteration, and we have a little bit cleaner check for if this is a valid spawn coordination location. Let's rename this. Okay, so that's spawn locations, and this is Let's rename this to level spawn locations. And it's a little bit verbose. But then I think that's pretty good. Let's see what the compiler thinks. And we'll also maybe take a few more minutes. I do want to wrap up today, but let's take a few more minutes and clean up some of the stuff here. We'll also re-enable the keep inside walls if this compiles. Complaining about dead code. Let's see. Do we have any ghosts spawning? We do not. Okay, so I think there's some problem there. What I'm guessing is that our new system that we created in levels does not let's put in some printouts here. Got a ground tile at grid chords. Okay, so it is getting ground tile. So we are putting stuff in there, right? Let's look over here. Let's change that to return. And then if we get to here, yeah, if we get down here, we could say if we don't short circuit that, we can say didn't find a spot to spawn in, and then we'll inspect the level spawn locations. Because there may be something I'm doing wrong here with the we don't need this anymore. With the contents of this resource. And I would love to see what the contents are if it doesn't work. Oh yeah, see, it's empty. So we did something wrong there. And I quit Zed. I didn't mean to quit Zed. I meant to quit the game. Okay. So our level spawn locations didn't return anything. So this level, there we go. Now we're starting to get it. I don't need to clone that anymore. I can just say into. Right? No. Let's put that back. Another thing that we could do potentially is rather than store this by level ID in that map, Let's put an info in here. Da, da, da. If that level ID has like Aster, has get, we could make this contain a string. The thing is, it doesn't, level ID doesn't implement borrow for string. I mean, it's got a blanket implementation, but it doesn't implement borrow for string, so we can't use that. But yeah, let's change this to a hash map from string to hash set. And then, yeah, so that gets us a string, we clone it. And let's put the contents in there. And let's do cache, let's say caching spawn locations for ID. And then we'll inspect contents. Okay, because I want to see what we're getting here, and then over here we can remove this printout because we didn't get any spawn locations there. What's wrong here? Oh, right. So we need to get this. We don't need to do clone into here. We need to do level ID, and then here it's stir. Okay. What's interesting is that this is getting overwritten. That's the problem. So every time we're running this, we're starting out with the correct thing and then we're overwriting it. So what's curious to me is like why the other one is working with the added and this one is not. Oh, okay. So we need to make sure that the query is not empty. So we say if ground query is empty, return. We don't care because there's no point in clearing all those out. Otherwise, what we do is we create an empty hash map, and then we go through all the levels and set their values to the empty contents there. So, okay, we figured that out. And then it only sets it once, and now we're getting Argos spawned. And let's go up here to the edge and make sure they don't spawn outside the wall. And they are not. That's good. Let's go over to the right. We'll need to fix that, make our weapons die when they hit the walls. Okay. That's looking good. Let's remove that info. And let's inline that variable. Okay. And now, finally, the thing we were trying to get back to is we can make the ghosts stay inside the walls, because they'll never be spawned outside them now. I had no idea that was going to be that crazy, but here we are. Thank you for sticking around if you're still here, and I think this is a good place to wrap it. I'll make a commit real quick. And we'll add source. I actually want to... Let's reset that, because we're not using... I think we're not using ECS tile map anywhere. I think, yeah, we'll do one more thing before we go, and I'll clean up dead code on some things. We'll remove some commented out arguments and things like that. Okay, so let's see, ghost, we're not using wall tile. Spawn locations. We're not using either of these, so that's good. Yeah, now it's no longer declared, so let's run check again. Okay. All right, in levels, we're not using tile size because we're pulling it from the layer information. So we can get rid of both of those. And then in movement, we're not using new. Okay. For velocity. Okay. All right, let's run cargo check again. No warnings. All right. And let's add assets and source. Let's look at our to-dos. I think I'll go ahead and commit this. We did keep inside walls. We spawned enemies inside the level. We cleaned up the dead code. We can leave that. We might say something or write down some things that we want to do next time. I may do that between sessions. But wow, I think we solved a really complicated problem today, and that's really great. Let's keep that running to do. Okay, so this is session 11. No, we did 11 last week. Session 12. I think that's correct. Let's real quick look at my YouTube channel. Except you don't want to look at my subscriptions. So we've got session 11 last time. Yep. So this is session 12, spawning ghosts inside the level. Let's say spawning enemies. And I think, do we re-enable wall collisions for ghosts? Yes, we did. Okay. We might look into, in a future one, tagging these with, something like stays inside walls as a component, and then it won't have to be generic. It'll just operate on every single thing that has that tag on it. Okay. We got everything staged. Okay. And let's push. and I will see you all next time. Thanks for coming and sticking around through figuring that out. And we'll do some more next week. Cheers.